Well, good morning. My name is Matt Luger. I'm from the North Dakota DOT. I will really quickly introduce our panel of experts that we have today. So we have Sudhir Pal is the program manager with Kentucky Transportation Center, University of Kentucky. We have Tom Matthews, transportation engineer with the Kentucky Transportation Cabinet. Derek Castle, the technical marketing manager for Bridge and Highway with Sherwin-Williams. Mike Bass, the senior project manager with GPI. And Brad Wilder, the director of standards, AMP, Association of Material Protection and Performance. And so real quick about my background with North Dakota, we are a very small organization. I spent my first 10 years in materials and research, and because of our size, I know a lot about I know a little about a lot of things and a lot about nothing. So in 2019, I made a right turn and moved to our bridge division and started doing load rating for them. When I was in materials and research, I was an SSPC member, so I knew a little about coatings. When I moved to do load rating, I went back to the book and dusted off the calculator and quickly lost a lot of my coatings knowledge. And one of the things I did was I helped rewrite our spec for structural steel coatings, moved to a 3-coat organic zinc system, and everything in our standards references SSPC standards. And so my first question for Brad here was, do I need to go back to those specs and change everything to the merged standards, or do those still stand and going into the future as well?
Yeah, so great question, and I'll say real quick before I get started, I was a contractor for 13 years, so I'm new to the AMP staff. I've been involved as a volunteer for a long time with standards and the QP programs, if any of you spec QP1, QP2. But yeah, since the merger, we've had lots of questions. What happens with the old standards? So AMP was created nearly 2 years ago by a merger of NACE and SSPC. You probably have those standards in your specs. The names of the old standards will not change. So if you have SSPC NACE, so there are lots of joint standards, so thanks for the shout out to those. Pete, you'll see the surface prep standards in particular, a lot of those were joint NACE, SSPC, and those names will stay the same.
Just to follow up on that, on the joint standards, if when you put a specification together, if you're strictly using the SSPC, SP10, you really need to document that in your specification or special notes with the joint standard of SSPC SP10 NACE 2. From a legal standpoint, that can cause problems down the road. So make sure that anybody who's doing spec writing or proposal writing needs to make sure that they address the whole moniker for those standards.
I'll add another thing. It's not necessarily standards, but a lot of your specs probably also have inspector certification. So the names of some of those things might change because they have, yeah, so the new, what used to be the CIP level 1, 2, 3, they all have new names, and I don't remember all the names now, but you might want to look at those. We're seeing that in some other industries too, where they're having to go back and sort of relick those specs and put those new names in.
I have an odd question. I have a really big bridge where a lot of the interior steel, and not a lot, but I would say 10% of the interior steel has lost its paint. It's down to mill scale. But mill scale doesn't seem to rust. So do I need to do anything if my purpose is to keep my steel intact?
By interior steel, is this a tub girder type interior, or is it exposed? Is it just interior beams in a multi-beam?
It's a multi-girder, 25 beams wide.
Okay.
So interior by not a fascia.
Is it safe to presume it's an old lead structure?
Yeah.
So regular mild steel, probably grade 70 steel, is anodic to mill scale. Mill scale is a great protectant of that steel until it gets damaged, nicked, banged, or falls off for whatever reason. Then you'll have rust. But if you've got a good solid deck over it, you're not getting a lot of aerosolized salts up on it. You go back to what Pete was talking about earlier. It's you have to do a risk analysis. Is it degrading to a point where you feel you need to do something about it? Do you have significant rusting? Do you have significant section loss? If you don't, and it's purely aesthetics, when you're looking at costs, I would say maybe not. And Tom, you deal with writing specifications for Kentucky. Is that something you want to weigh in on?
Like we usually put back the full coat system, the 3-coat system is what we typically use, and we do an overcoat or two every once in a while. But you know, we never have come to that solution. But we've got a lot of that stuff, like where the paint's off of it. We haven't got the bridges painted yet, and the mill scale's still there. You know, like I have one that's getting ready to come up that we're going to do the full removal because it is an older structure with lead.
It's just you got a mile long.
Yeah.
And you're gonna paint how much? And,
Yeah.
I mean, we just did, this is what we did zone,
Yeah.
beam ends and fascias, and that was millions of dollars.
Yeah.
I can't imagine what the cost would be to do 100%.
Yeah.
So Sarah, I know we work in both downstate and D1, and the zone painting is utilized statewide, and it's utilized pretty well in most cases. So again, I think you kind of defer to Pete's analysis there. If you aren't seeing significant section loss or significant breakdown of the rest of the coating system or rusting on the steel, I don't see a reason to expend the money on it. If you're taking care of your bad, the bridges scream at you and tell you where they have problems. And if you take care of those problems, you don't have to test for chlorides. You know they're there. That you wouldn't have that level of rust if they didn't. So I think in that case, I personally wouldn't get real excited about taking that mill scale off and repainting that.
And just to expand on that a little further, Sudhir, if you have anything from a research background on that topic at all, or?
Not much on the mill scale aspect of it, but we have basically, when the research was done, I mean, we always used to take out the mill scale and just do the whole thing. So on the mill scale, I'll refer back to the experts over here. So yeah.
Wrap that up, as long as the mill scale's intact, you're probably not doing, and your aesthetics are suitable. You know, it's interior beams, you're not seeing much of them anyway. Probably wouldn't worry too much about it. From a coating standpoint, there's no reason to put zinc over mill scale. That's not going to help you. So if you try to overcoat it just to give it some extra life or improve aesthetics, for whatever reason for that, just remember the coatings, regardless of who they come from, are only as good as what they stick to. And the mill scale will eventually turn loose.
Just to turn the topic a little bit, we had some presentations earlier in this room on coatings. We started off talking about galvanizing and metallizing. We talked about maintaining our most often used coatings, getting rid of lead, move to organic and inorganic zinc coating systems and somebody call me out if I'm out of line on calling it a 20-year system. Obviously that can vary, but there was some discussion between our panel members on if there's coatings out there that have a longer life, high performance coatings, and what the interest is in the room for that. From an agency standpoint, I would say that yes, I'm interested in learning more. I don't know if there's other agencies in the room. I'm looking for green tags. But there might be a discrepancy there between what agencies want and what industry can provide.
Just to add to what Matt was talking about is 5-6 years ago, we, when I say we, basically I'm with the Kentucky Transportation Center here at University of Kentucky. In partnership with the cabinet, Kentucky Transportation Cabinet, we put out a pool fund study looking to basically how do we bring into, basically make the high performance coating systems, how do we test them? And what is the mechanisms, that we can employ to test those systems, I guess. That's where this question is coming from is, does the current MWBPP standard, which is the ASTM D5894, majority of it, is that sufficient to test the high performance coating systems? In my opinion, no. A lot of you will agree to that too. There are, several ideas out there, but I would like to know basically from the DOTs or even from industry basically, how do we bring them into mainstream, I guess. That's the big question is high performance coating systems. I'll include even the metallizing and galvanizing into that. We're talking about 7,500 years of the metallizing. How do we test those? Test them to failure, basically.
to expand on that a little bit, and I don't think I told everybody this earlier, I retired from Kentucky Transportation Cabinet. I was over the bridge painting program from the construction standpoint, and the specifiers, which is what Tom does now for the cabinet, we work very closely hand in hand to put projects together and then see them through to completion. What we're looking at here, for those who aren't familiar with coatings approval processes, NetPep is widely used nationwide. That's a raw data program, and it runs coating products systems through a battery of tests, and it's, what is the ASTM, 5894, which is salt fog, and I think QUV is in it. I can't remember all the what exactly happens, but it tries to beat the coatings up. It's accelerated weathering. The problem is there right now is no way to differentiate if the bar is set at this level, coatings that a commodity product that gets just above that or something that's up here. There's no differentiation. These products are going to be at a certain price point. These products up here may cost considerably more, but they may give you considerably more life cycle. That creates a couple of problems. One, there's no way to identify them, and now there's no incentive for the manufacturers to try to do research and development to create a product, whether it's a galvanizing, whether it's a thin film coating, regardless of what chemistry or metallurgy it might be. There's no incentive, because right now those commodity products are what everybody's going to use. The contractors are going to go with the cheapest that they can readily access right now to be able to meet the minimum standards that the DOTs require. So the question was, and unfortunately that pooled funding study fell apart when I retired because we couldn't bring everybody together to proceed with it. But the question to the DOTs is, would you be interested in having materials available that would give you, right now, if you go out and take the lead off of a bridge, or take the old zinc system off of a bridge and go back with the zinc epoxy urethane system, depending on its exposure, depending on salt impregnation and so forth, you're looking at 20, 25, you might get a little longer in a rural setting, a little bit more life cycle out of it, but you're looking at a 20, 25-year life cycle on that coating system, and possibly less in certain areas where you may have to zone paint, right? So do you want something that, because painting's not going away. There's too many old bridges out there that we're going to have to maintain through protective coating systems. Do you want something that maybe will give you a 30, a 35, 40-year life cycle? And if you do, are you willing to help get involved in coming up with a new battery of tests that will beat that up in an accelerated weathering, so that we can raise that bar from where it is now to up here, and give these guys incentive to produce something like
It goes beyond the testing as well. There's looking at proactive specification writing, because the specifications are written now for minimum level performance, or they're written for either formulation-based specifications for coatings or hybrid specifications, which are essentially physical property parameters, density, ranges on densities, viscosity, weight solids, percent pigment, dry times. Or they're written as a performance specification based on the accelerated testing performance either through an in-house testing program, third-party analysis, or the MWBPP program would actually fall under third-party as well. So being able to work with specification writers to develop tiered level specifications where you have a toolbox of opportunities, options, in order to specify different level coating system, different level performance expectations, is going to have to go hand in hand with any additional testing, because simply just doing additional testing, rewriting a test standard, whatever, one, it's going to take time. Two, it's going to take even more time, not only to run the test, but to develop the adoption. Because let's face it, the DOTs, and I was with the DOT for 20 years before I came to the coating side, the manufacturer side, they're not quick adopters of new technologies or new trends. The DOTs tend to sit back and watch what everybody else does for a while and then move on. So I get it, was there, did that for a long time.
Would it be, if we wanted to specify something that would be at that higher threshold, is it as simple as putting the number of hours in the salt spray at a higher level, or is it a complete rewrite of the test that NetPep or others are doing?
So there are states that have looked at increased hours of testing and accelerated weathering. The reality is the current battery of testing is typically 5,000 hours. by the time you, especially going through the MWBPP program, which there's nothing wrong with the program, it is 9 months from the time you submit as a manufacturer till the time you get results out for the DOTs to look at. You are looking at 9 months. We're, from a manufacturer's perspective, we plan that as a year. By the time we submit, we get the test back, we go to talk to DOTs, we present information and data. We're looking at a year cycle. Now, building new technologies or improving technologies, you start building R&D time in front of that, you're looking at multi-years in front of that. So now if you're going to take a couple of years of R&D and you're going to double the testing cycle, you're going to go from 9 months to 18 months just for the test cycle. Now you're 2 years out, where the return on investment in R&D starts to drop quickly. So I don't, and some of the states that have done extended weathering cycling, they haven't really seen any differential data out of that. Matter of fact, one of the states that did a very extensive study into it determined that if you were paying close enough attention to the data analysis, you found you had everything you needed to know within the 5,000 hours or potentially less. And you could put that into a calculation, into a modeling data, a modeling set, and you had everything you need to know to make decisions on QPL or approval processes in 5,000 hours or less of the current testing. Now that's based on the current acceptance parameters. I was involved with Mike and Sadir back in that pool fund study, and one of the things that we were talking about was not only either modification of the existing testing or development of a whole new test parameter, but we were also looking at the evaluation criteria. Because if you're not familiar with the evaluation criteria, these tests we're talking about, they take a steel panel, you coat them, you put an intentional defect in them, you scribe them to the bare steel, to the substrate. And then you put them in salt fog cabinets and you let them run for 5,000 hours and you do intermediate testing. At the end, you scrape them and you evaluate them. And the reality is you're measuring rust creep, so a linear distance of how far the rust moves from the intentional scribe out under the coating and peels the coating off. And you're measuring it with a glorified school ruler, measuring it in millimeters, visual analysis. So there are electrochemical processes, there are other evaluation tools that that are developed and could be used to probably get to results that we're looking at now even faster. So.
And I was just going to say from where I see it in the association space, seeing across industries, this is not a DOT specific concern. I mean, everybody is facing the same issue of we need our assets to last longer, we want to touch them less often, spend less money, be more sustainable. So DOT, DOD, oil and gas, maritime, everybody's asking these same kind of questions. How do we make it last longer? And how do we know it's going to last longer? That's the hard thing, right? You know, old three-coast systems, you know, Pete could go out on a bridge in 20 years and say, how did it perform? Well, how do you do that with a 50-year system, a 75-year system? Do you let the next generation come along and evaluate that, and then you make decisions? It's not practical. So there's got to be ways to say, okay, this is a good idea. It's coming out of R&D. Let's figure out a way to test it and see if we have a probability of success here.
So one of the questions I have is so you've got this 5894, but if you test galvanizing or metallizing, that it's going to fail right away. And my question is, what about the IOZs? I know the National Steel Bridge Alliance is going around and looking at IOZ bridges that are 30 years old that are still in fine shape. I know there's some organic zinc bridges, just organic zinc bridges that are 30 years old that aren't failing. How do we get those in the evaluation when we know in these type of tests they're not going to do real well, but we got case studies where, you know what, they're in fine, pristine shapes.
That was the impetus for discussion of building a new test, because the primary testing, whether it's DOT market segment or oil and gas or basically any other, for accelerated testing is based on ASTM D5894 cyclic weathering, which is salt fog testing with UV combination, or the even older test method, ASTM B117, straight salt fog. You're right, metallizing, galvanizing do not do well in those tests. That's one of the arguments the coatings manufacturers have had for a long time now, or one of that metallizing, galvanizing is accepted and used quite frequently with little to no testing, when the coatings manufacturers are held to very high levels of testing and repetitive testing, so to prove their systems. So looking at as far as B5894 or B117, B117 has very little correlation coefficient to real world unless you're Golden Gate Bridge, because it is basically a complete wet salt fog. There's no little drying effort in that test process. So Golden Gate Bridge is in a salt fog bath. If you've ever been on the bridge, it's wet most of the time. So that test correlates for them fairly well. B58 or D5894 has a wetting and drying cycling with UV added. It correlates better to real world, but it's not nowhere near a perfect correlation. And the reality is, coatings on bridges don't fail at an intentional scribe line. They don't fail at an intentional defect. So need to be more research into how to better accelerate and mimic the actual failure mechanism that's seen in the real world.
This question is for Brad. If you could put your old contractor hat on and maybe share with us some of your thoughts from, what's good and what's bad from a perspective of what we as designers or as bridge owners might be providing you as a contractor to make sure that we get that desired life that you just talked about, not having to go back out and retouch that.
I would say, if I could give any general advice, over-communicate, set very clear expectations even before the bid. And Kentucky did a great job of doing mandatory pre-bids, of answering questions truthfully and completely. And so you have a pre-bid Q&A session. We used to joke all the time. Well, we would ask a question and they would answer bid per the spec. Well, we're asking the question because we don't understand the spec, which means our competition probably also doesn't understand the spec. So I would say that the DOT, the owners, the consultants working on their behalf, answer the questions as completely as possible, set very clear expectations for all bidders and all contractors, and I think that's going to help set the right tone that the work you're doing has a very set way, and it's going to be inspected a set way, and you know what you're getting into. Because if you get in a situation where a contractor feels like they need to cut corners and get through the job quickly, that's where you're going to have problems.
Comment on that both from former DOT and as a consultant providing services to multiple DOTs now. Brad is absolutely right. The communications, being able to clarify the intent of a specification makes a big deal, a big difference. Having a preferably single point of contact for that clarification is ideal. With working with various agencies, some are centralized, some are decentralized. But you'd never really know who to go to. The vast majority, and this is not a knock on anybody, but the vast majority of the area engineers, resident engineers, section engineers, whatever moniker they happen to have, are very unfamiliar with bridge painting. It's not something they study in school. It's mostly something they don't really care about. They just get stuck with a project and they have to deal with it. They bring in-house or third-party consultants to do quality assurance inspection, and hopefully those people have been around and experienced enough that they understand the particular specification. But having availability of someone from the owner agency, regardless of, we're all DOT, but regardless of what that owner agency is, that can clarify the intent and the what they're looking for on that project and what they mean by the way that it's written makes a big difference. And again, Brad hit the nail on the head. You've got to have that communication, and you have to have those open lines of communication and who to ask those questions of. Specifically to the engineer, consultant, spec writer crowd too. Some of the worst disputes I ever saw on projects was where the spec did something that was a non-standard, maybe different than everybody else did. So for example, the standard for DFT measurements, PA2. So there are a few owners that will basically write their own way to do PA2. So the contractors come on the job, they're expecting that, and they get something a little different. The third-party inspectors come on the job, they know PA2, they're expecting to do that, but they get something a little different, and it ends up being a dispute on the job site, and that's not a good place to be either. So I would say, try to harmonize your specs as much as possible. Use standards. If there's not a standard, kind of see what everybody else is doing and know your contractor market and where they're working, and try to have some consistency in what you're asking the contractor market to do on your job. Pass this back. We'll pass the mic back and forth a little bit because you may, and I know it's another I know it's going to refer to another moderator question, but you bring something to light with specification. So there's no such thing as a bulletproof spec. There are some very good specs out there, and most all the agencies we work with in the Midwest have good specs. But one of the problems I have foreseen, or not foreseen, but I do see, is that some of the specs, to be able to see the complete spec, you have to bounce from a special note to a plan sheet to a written spec, and you may have 4 or 5 sources outside of standard, industry standard references to go to, and to compile all that together can be kind of difficult. And I think everybody here probably knows that some of your contractors may not be well versed in English. Some of the workforce may not speak English at all. So having a single source or minimizing the information, having it in one spot to go to be able to get everything you need to know to be able to bid that job and to be able to inspect that job helps tremendously.
I did have a follow-up to something that we were talking about earlier. Is you mentioned that there's a lot of room here for additional research, maybe new test methods, and mentioned a pooled fund study that may have fallen apart. Was that just a Kentucky study, or was it broader than that?
It was sponsored by the Transportation Cabinet, but it was put up on the pool fund study on TRB. So I think it's poolfund.org. Of course, it has been taken down, because it was put up in 2017, and since we didn't get any interest, it was taken down. But if anybody is interested, do contact me, and then we can definitely, talk about it and try to put it back up, and then see if we can get more interest.
Right, and that was my point. Is that it seems like that whole issue does really affect everybody here, whether it's contractor, consultant, DOT, manufacturers, industry. It's across the board, and you got to get everybody together to try to iron something.
The reason it was going to need to be a pooled fund is because it was going to be an expensive research project. You were talking about building prototype testing equipment, and there's no single DOT or federal highway agency that works with the DOT that was going to approve the amounts of money necessary to get that off the ground. So, and I don't remember the cost figures that were estimated at the time, but yeah, that's why it was going to have to be multiple agencies involved in helping to fund that project.
Well, this is a question maybe for Derek. And Pete mentioned some of the work that he's been doing and with the naval, the DOD and the Navy. Is there something that you're aware of as a paint supplier that they're doing, and maybe anybody else can talk to this too, but that they're doing that we should be adopting as a bridge industry? Is there something like, why do we have to do $1 million study if the DOD is already doing something that's working? Is there a way that we can collaborate with them? And as a paint supplier, are you seeing that? Are they requiring something from you that we as the bridge industry should be thinking about?
There's always discussions about test methodologies and changing test methodologies. So back up just one piece. Everybody should understand that there's D5894, B117, those are tried and true test methods. They've been around for many years. They are comparative test methodologies. They were always built to be comparative test methodologies. If you had a coding system that you had field experience with, local knowledge of, that you were happy with, that was supposed to be run as a control in either or both of those tests to evaluate new candidate systems to see if they performed equally or better. So that's how both of those test methodologies work. That's how the NTPEP program sets up control systems that are run with it. So it's the same control with every set of tests. So there is a comparative methodology available through that data. That's all things that have to be built as you move toward a new test program or new test protocol. As far as other industries, something that we at least found is interesting is the Navy, the U.S. Navy, DOD. For a number of years now, they've been doing a significant amount of work in ultra-high solids products. Low VOC, no VOC, ultra-high solids, and relatively ultra-high film build. That's made its way into some of the oil and gas market And I think it's certainly of interest to me from within my company to look at those technologies and some of those films as how they perform. Because it's, at the end of the day, flat mild steel is flat mild steel. It really doesn't matter what shape it's in. You get some different environmental configuration, some different environmental impacts and configuration impacts. But if an ultra high solids epoxy at 150 mils works on a ship and works on an offshore sea platform, maybe it'd work on a bridge. Now, that's a complete mind shift because everybody's worried about coatings weight and too many, when back in the day when overcoating was hot and heavy, owners were worried, consultants were worried about how much coating is on the structure and what's its condition and how much more can we put on it before it delaminates and falls off in sheets the size of school buses. So you go talk to an owner about putting 100 mils of a ultra high solids epoxy on their structure, they're going to look at you like you got 3 eyes and 4 noses. We've entertained the idea of running some internal testing on ultra high solids epoxies at more moderate film builds, still well above the traditional 12, 15 mils in a 3-coat system, but so far we've not progressed that much. This little thing called COVID and the supply chain kind of screwed that up.
I would say there's lots of interesting opportunities to share knowledge with people like DoD. So I was on a call a few weeks ago, and you can imagine something like an aircraft carrier deck. It's getting blasted by jets all day, every day. So, how do they deal with that? Well, they're doing a lot of thermal spray non-skid and learning a lot of good lessons from that and how to keep it adhered. And then they bring the ship into dry dock. How do they get the striping off without damaging the non-skid? So they're doing stuff with water blasting and stuff. A bridge deck is not that dissimilar. If you are working on a bridge deck, are there lessons you can learn from, Navy research or Navy practice? So, yeah, I think these kinds of meetings are great. You come here and talk to people that are doing your same job, but I would encourage you too to go to some meetings and talk to people doing Navy work or Marine work or whatever the case may be. Like Derek said, it's all steel and concrete and coatings and chemicals and abrasives, and we're all dealing with the same materials and a lot of the same processes. So I think there's some good opportunities there now that we're not in COVID anymore to go talk to some people.
Just to add to that, you're right, challenges are very similar, the details are a little bit different, there's a lot to learn from each other. I like your idea, Derek, about taking the ultra high solids. There actually is a DoD initiative that I believe is funded by the Air Force. It's been going on for a lot of years where they're trying to get at this testing piece, and they're trying to understand how salts and moisture and all that interact with the surface and understand like what's literally going on the surface and how they can model that and vary that stress instead of the macro environment, right? And then they also have some electrochemical sensors that are embedded underneath the paint. So they're getting at this permeability issue. A lot of really good work that might be able to be leveraged. So
I'll maybe shift gears just a little bit to look at more the construction side, and I'll just open this up to the group, whoever wants to answer. What processes are most troublesome when applying coatings, and are there any specification, training, QC/QA improvements that can be made to streamline the process?
Which one you two want to start there?
Looking at the contractor now again. So, I will say on the QC, QA side, our industry is still very much in that do the work, then inspect it again. It's a very inefficient process, right? A lot of the world, manufacturing stuff, they've moved on from that. It's more of a process control philosophy of QC is get the process right so it's never going to be wrong when you get to the inspection phase. So, I would say whenever possible, try to have that mindset. How can we control the process? How can we find those trouble areas, which are like, beam ends and inside connections and places that are really going to be trouble, because you're not going to have trouble on the web of a girder. That's an easy place to paint. So, how much time do we really need to spend taking film measurements on the web? You got to go where the places it's hard to get and learn where those places in the process are, where the processes are that are difficult to do and need extra attention, and maybe some slight adjustments while you're doing the work can keep from having that problem on the end and having to fix it you do repair procedures, and that opens up a whole other can of worms and a lot of costs and a lot of time to a project. And if you're out on the interstate in the middle of the night trying to paint an overpass and you're waiting until the paint is dry to go find the issues, then you're adding yourselves a lot of trouble and a lot of cost.
In relation to what Brad says about in process, everything is QC QA typically, but if a contractor, and Sarah brought up having a 5-hour lane closure to set up your containment, get in, do the work, and get back out and drop your lane closure. Very limited time frame. So the quality control really needs to start with the people doing the work. I don't know how infrequently I see paint applicators with a wet film gauge or even know how to use a wet film gauge, but you don't see it very often, not nearly as often as you should see it. If they've got a wet film gauge, they can be doing the QC as they're going through. Now, it's not the formal QC that the QC inspector's doing, but they're doing quality control. And I believe that's where quality control starts. So contractors have that option available to them to initiate quality control on the front end. And then what's been touched on already with all of it, it's communication, communication, communication. Everybody needs to be on the same page what the expectations are that you're going to be looking for and how those are going to be achieved. And if there is additional rework, how that's going to be done too, to just maximize the efficiency on any of these projects.
Tom, could you maybe talk to what you're seeing at Kentucky in terms of kind of what Sarah pointed out as well, that it's got to kind of start upstream in the design end and in the spec end. And like, what are you seeing, or how are you all collaborating to kind of make that happen so that when he used to get the job, he would be able to do a job well enough that, when Mike was out there inspecting, wasn't saying, hey, come back here to there. Like, is there something you could maybe share with the group about how you guys are collaborating on that?
Well, we just generally, as Mike says, we do the QC QA process that's written in our spec, and we have these points of inspection that they're supposed to follow in the spec, and we just rely on our inspectors, because right now we're using GPI. They're our consultant selected contractor for the period of time now, because we're running low on inspectors that are actual in-house, but they're just follow the guidelines that we have written in our standard specification.
What about upstream in design? Are you collaborating with your design folk at all, or is it?
It just comes down to me and us. That's the way it always worked. It's a bridge preservation branch where I work at, and I'm pretty much it. And I deal a lot with the materials over where Derek used to work, and like we have an overseer in construction, as Mike did, that I work with just to see that these things are followed out, and they usually come to me to tell me if there is an issue, and we try to resolve it at that point.
I haven't been very close to any projects that what the supply chain issues are out there currently. I'm sure Derek can expand on that, but in my previous experience, I did run into some projects where we needed to make a substitute of a coating, and the coatings are allowed on the manufacturer's data sheets, but they're not necessarily the system that was tested in NetPep. And so we kind of created our own bind where our specs say one thing, it has to be this NetPep product, and now due to a substitution, the supplier needs us to use something else. And just if you could speak on how we can work through some of those issues.
So in general terms, the supply chain, while there are still hiccups, the supply chain is improving for the coatings industry. At this point, as much as anything, it's a demand is simply outstripping production. So there's a lot of pent-up demand, a lot of projects delayed because of workforce as well as supply chain issues over the past 2 years. And manufacturing is at capacity, at least for us, and we're still we're hand-to-mouth feeding, trying to supply projects as best we can, and that goes for most of our competitors. A couple of our competitors do have a more of a hiccup in their supply chain issue because they were more reliant on a particular raw material supplier that had a fire back earlier in the year, and that plant has not returned to service. So that's creating a bigger problem for some other manufacturers than us. But by and large, the supply of raw materials are improving, and it's our expectation or anticipation that as, especially in the bridge market, as the season is coming to a close for most of the states above the Mason-Dixon line at least, that project speed will slow, or project demand will slow some, and that will give us opportunity to rebuild inventory. Prior to the pandemic, manufacturers would have run through the winter and would have built stockpiles of material, especially the core line products, and so production may never have really met demand, but we had inventory, pre-existing inventory that we could ride, and then we would rebuild in the winter. So we're hopeful to get back to being able to stock the delivery centers, distribution centers over the winter months, and be in a better position come spring of '23. Now, as far as addressing substitution materials, in the current climate, with still some restriction or some availability issues on raw materials, most manufacturers have streamlined their manufacturing processes to only their core line products. So in right now, being open-minded is great, but the reality is you may choose another product off a particular product data sheet that is less available than what you were trying to get to start with, because the manufacturer may not be making it at all. Just to conserve raw materials and conserve production space, production time, focusing on those core line products. From a testing standpoint, there's finite costing available with testing, required for testing. So the more products tested, the more expenditure on the manufacturer side, and quite honestly, once you get outside of the core line products that are on the majority of QPLs across the country, there's little return on that investment. So, but the best thing I could encourage is following in the same theme of communication on the contract side, is communication with your coating supplier, your communication with your contractor when they bid the job, when they're awarded the job. As soon as that job is awarded, need to be encouraging them to contact their coatings manufacturer and place the orders as early as possible in the process, to give as much leeway, as much lead time as possible to get those materials delivered. That's probably the best way to navigate through the back end of this supply chain issue.
A round of applause. Guys, thanks so much. Appreciate that. I got to do the mandatory thank yous to folks. So if you just hang in with a minute, we want to thank our platinum sponsors, AECOM, ICC Distribution Group, and Stantec. Stop by their booths, please.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.